Learning target 2.11. I know electrostatic attraction is responsible for the stability of an ionic bond and results in the formation of a salt crystal. Okay, so first, what is electrostatic attraction? Let's go ahead and write that down. Electrostatic attraction. That is the attraction between two electrically charged bodies. Outside of the chemistry context, you guys are actually really familiar with this. I'm going to give you two examples and you'll know exactly what I mean when I'm talking about electrostatic attraction. Okay, so here's you. I'm just going to assume everybody who's watching this is a girl. All right, here's you. Here's your friend who's a giant hater and wants to mess with you by putting a balloon next to your hair. What's going to happen? Your hair sticks to the balloon, right? The reason why is electrostatic attraction. Here's another example. I'm just going to assume this time that you're all boys. This is you as a boy wearing socks. This is you as a boy wearing socks on carpet. This is you as a boy on socks wearing carpets trying to mess with a friend. This friend is not so happy. Why is this friend not happy? Because you're about to rub your feet on the carpet. You're going to charge yourself up and you're going to... Oh my God. Sorry, that's my dog. Excuse me. I'm not going to start over this video because I just want to get through this. Okay, this is you and your friend. You're about to zap your friend. He's not happy. Okay, what are both of these examples of? They're both examples of electrostatic attraction. Basically, what you're doing is you're charging one side of something, right? And the other side, you're sort of going to pull all the electrons away, right? That's that zap that you hear or feel. Okay, so what does this all have to do with in terms of chemistry? Well, in chemistry, we're going to talk about it as an attraction of two electrically charged bodies. You guys know electrically charged bodies. You know them as ions. You have positive ions and you have negative ions. It's cation and an anion. Okay, so the electrostatic attraction is responsible for the stability of an ionic bond. That makes sense. You have your plus and your minus. They're going to pull together. That is called electrostatic. Now, if you have a whole bunch of them, the pluses are all going to bond with your minuses, and the minuses are going to bond with your pluses, and that's going to pull it together. It's going to pull it together anytime you have a plus and a minus. That is a salt crystal. So it's not just NaCl. It could be MgCl2. It could be NaCl. It could be NaF, right? Just anything that's a positively charged ion and a negatively charged ion together is called a salt. It's good to remember. Okay, they're electrically charged bodies. What it is electrons are going to jump from one side to the other, right? Because you're going to force all of your, one of them is charged, so it's going to force all your positives on one side, so they're going to jump back and forth, and that's where you get that zap from. Okay. Let's go ahead and take a look at a possible CST-like question as practice. Which of the following statements about BaCl2 best describes how the atoms are held together? Well, I'm talking about how atoms are held together. I'm talking about BaCl2. Ba is a metal, Cl is a non-metal, therefore this is ionic. Okay, keep that in mind. Let's start with down here. Barium ions and chloride ions are held together with a covalent bond. We know it's ionic. That's wrong. Barium ions and chloride ions are held together with dipole-dipole forces. That has to do with covalent bonds again. Alright, so that's basically you have two molecules, one's plus, one minus, right, one's plus, one minus, and it's just holding it together. You're making a dipole-dipole force. Okay. Barium ions are attracted to chloride ions with electrostatic forces. Wait, if it's ionic, it's your plus attracted to your minus. This is the correct answer. Electrostatic forces hold ionic compounds together. Let's just take a look at this top one just for fun. Right, London dispersion forces, or LDFs, cause an induced dipole in the molecule of BaCl. So many things wrong with this statement. First of all, BaCl2 is not a molecule, right? Molecule tends to be things that are covalently bonded. So you're not forcing Ba and Cl to have a dipole, right? That's a London dispersion force. That's induced, forcing something to have a dipole. It actually is already charged. It's already polar, right? So that's not it. The correct answer, again, is barium ions are attracted to chloride ions with electrostatic forces.